Hello everyone, June the 12th. Alright, let's do this. Minimum number of moves to seat everyone. There are n seats and n students in the room. You're given an array seats of length n, where seats I is the position of the ith seat. You are also given the array students of length n, where students j is the position of the jth student. You may perform the following move any number of times. Increase or decrease the position of the ith student by 1. Return the minimum number of moves required to move each student to a seat, such that no two students are in the same seat. There may be multiple seats or students in the same position at the beginning. Okay, so at the beginning we have positions of seats at 3, 1, 5. Okay, so if we write it out, 0, okay, 1, 2, 3, 4, 5, 6, 7. So we have seats at 3, at 1, and at 5, and seats cannot move. The only thing to move is a student, and each step increase or decrease the position of the ith student by 1, and the students is at position 2, 7, and 4. So what we want to achieve is to move each student to a seat, such that no two students are in the same seat. So just spread the students into all the chairs and then finding the minimum way to do so. Well, in this case, definitely you can move this one here, move this one here, and move this one here. So that's 4, right? That's 4. So yeah, basically you have some positions, you have some position and you have some others. You just need to move them towards it and find a minimum. And it's pretty straightforward that if you are on the edge, you have to go here. If you're on the edge, you have to go here, because if you go inside, then if you go inside and these one has to go outside, then the amount of distance that need to travel will always be more, right? Will always be more. Like so there are only 2 scenarios for the outside. So either outside is here, right? So if this is here, they want to get to this one and this one go on here, then you always have to do, this extra distance, right? Extra distance. If it's inside, if we do this and then, like if we have, I don't know, like this scenario, we have 2 seats here, 2 people here, and that's the front, the leftmost. If we do this way and this way, then we are traveling extra, right? Because for each student, you need to go, think about this way, right? The leftmost seat shall be filled by the leftmost student, because otherwise every other students who are coming here will have to travel more, right? And the same thing, you should do this one, right? Even if this one's more to the left, then if you go anyone else, will incur more distance. Yeah, so for everyone, so basically what I think is you have the seat, you sort the students, you have the smallest seat, you sort the seats as well, you sort both, and the leftmost should go to the leftmost student, and then just like that. Okay, so let's see if this theory works. So now our seats is 1, 4, 5, 9, and our student is 1, 2, 3, and 6. So in your theory, so it shall be a 0 plus 2 plus 2 plus 3. So that will give you 7. Okay, that's good. How about the last one? We have seats as 2266. And we have a student as 1236. So that will be 0. No, that's a 1 plus a 0 plus a 3 plus a 0. So that will be 4. So that's considered like what, greedy, right? It's like greedy because it makes sense. The leftmost seat must fit the leftmost student because any other fitting will cause extra steps because that's the closest, right? Even if the leftmost student is to the outside, because for the leftmost student, if you do any of the others, it will always cause more steps for that student. So yeah, I do think this is we can count this as greedy, right? We definitely can count this as greedy, I think. So basically, we need to sort seats and sort students, right? Students, and rest is 0. We just say I is 0, I smaller than seats dot length, I plus plus. Rest plus equal to seats. I think we have to do math.abs seats I minus student I, and we'll return rest. So I will call this 2037. A bit greedy here. The leftmost seat must be occupied by the leftmost student to minimize the number of steps. Because if we don't do it, right, you say we don't do it, then the leftmost will be occupied by somebody else. And then that will always lead to more steps. Would it always lead to more steps? I'm trying to figure out. Well, if that's, and then somewhere here we'll do that, right? So it's this plus this. If we do this, it will not be worse, right? It will not be worse. Okay, so that's kind of my thing. We need to see if it works. These definitely will work. Let's see, overall, does it work? It does. It does work. It won't be worse. Sorting and greedy. Oh, let's just sort different ways of sort. Okay, so we are good with this. Do they have like a good proof? Yeah, for each student who choose locally, I mean, that's not really for each student, it's just overall. But anyway, all right, now we can move on to this one. Minimum operations to make a special number. You're given a zero-indexed string representing a non-negative integer. In one operation, you can pick any digit of num and delete it. Note that if you delete all the digits of nums become 0. Return the minimal number of operations required to make num special. An integer x is considered special if it is divisible by 25. 25 is 5 times 5, right? So an integer divisible by 25, it must be, holy crap, what's the integer? Is it the last 2 digits has to be divisible by 25? What is the digit magic for something divisible by 25? So divisible by 5 is ending with 0 or 5 is divisible by 5, right? Anything, actually I'm not sure. What's the divisible by 5? Yeah, I think it's any number that's ending at 5 is divisible by 5, right? Yeah. But 25. 25. You want to observe? Let's see. 25. So basically, 25. So if I have 5a times 5b, right? I don't know. So something divisible by 5 can be represented by, yeah, it's like that. So if it's ending in 0, then this will definitely ending in 0. But not everything ending in 0 is divisible. Okay, it's 25, 50, right? Times 3. So 25 times 2 times 3 is 75. Times 4 times 5, right? 150. Oh, 175. It's, oh yeah, okay, 200. So that's, okay. So it has to be like 225, 250, 275, 300. Okay, so it doesn't matter, just the last 2 has to be this. So the last 2 has to be 25, 50, 75, or 00. So the first one, it's doing 50 and it works. This one, we have to remove 1, 2, 3. Become a 0, 0. And this we remove 1, so it's a 0. Okay, so we just need to go through this to find the first occurrence of these patterns, right? These patterns. How do we find these patterns? And they have to be as close to the right hand side as possible, because if we can find them early on the right hand side, then we don't have to worry about anything to the left. Anything to the left, we can keep it, right? So we go right to left. We record the first 0. We record a 0 where we find a 0. If we have a 0, then we're good. Or we find a 5, right? And then if we find a 0, we need to check, wow, what would be the good way to match this? We can run it twice, right? We run it twice. First round, we check the pattern of 5, 0, and a 0, 0. That's the first pattern. Going right to left, we check if we have a 5, 0 or we have a 0, 0. So we just go one by one. We check 0 and then we check if there is a 5 or if there is a 0, right? And if we don't find, if we don't find any, then shall reduce to 0, right? Shall reduce to, so, there are multiple scenarios, but this is only 100, so I think what I'm going to do is just go through all these scenarios. So we'll just go through those scenarios. We'll find 5, 0 first, see if there is one, going from right to left. That is wonderful here. Right, we go right to left, we find the first 5, 0 pattern, and after we find the first 5, 0 pattern, what we need to do is to remove everything to the right of 0 and remove everything in between. So we just get the index. No, hold on. We just get the index, right? We get the index of 0, the first 0 on the right hand side, right? And then the first 0 on the right hand side. Yeah, this is what we need. The first 0 on the right hand side, and the next and the 5, and then we get this, we get this. If any one of these works, and then we can find the number of digits need to be removed, right? So we get that. And if none of them works, then we just find the first 0. We just find if 0 exists, right? If 0 exists, then we'll remove everybody else. If 0 doesn't exist, there's no 0 in this, then we have to remove the whole thing. Okay. Let's give this a shot. 2844. Okay, so we're gonna go 2844. 2844. 2844. Okay, so first pattern. Yeah, I'm gonna say divisible by 25 means the number must end in 2550, 75 or 00. Right? If none of these pattern exists, we need to reduce num to 0. If there is a 0, then we remove remove all the other letters or digits. If no 0 exists, we remove the entire thing. Okay, so we can write a function. Pattern exist. Does pattern exist, right? Does pattern exists? So we'll do a pattern, which is a string, and then we return a Boolean value. Okay, so we go through num from right to left, and pattern is occurrence in indices, right? Indices equal to this. Okay, and then for pi is equal to from right to left. Okay, pi is equal to len pattern minus 1. Then for I in range len nums. Yeah, we can probably do this n equal to len nums. Okay. Because it's n, I don't have to do this. So n minus 1, minus 1, minus 1. Okay. If num I is equal to pattern pi, Okay. Then indices dot append I. Okay, indices dot append I, and pi minus equal 1. If pi is smaller than 0, we'll break. Right, pi minus equal 1, and then if it's now, just keep going until we find a second one. Okay, so when we get out, right, if now pattern exists, it is operations, num ops. So we're gonna return an int. All right, so we're gonna return this. So after we go through this, we'll check, right? We'll check the pi. If pi is smaller than 0, that means we have found it. Then we're gonna go into the indices and try to count the number that we need to remove, right? Then we say if pi is smaller than 0, then we'll return what? So all the digits, all the indices between indices, right? So what we're gonna do is we probably should add another one to the, well, I mean, technically we go, okay, so what we can say is pre, let's call pre is equal to len nums, right? That's n, right? And then let me see, if the indice is n minus 1, then we need to, oh, actually no, I think it should be like, well, how many digits, how many elements is between indices? Let's say 1 and 3. All right, 1, 2, 3. It's 3 minus 1 minus 1. Right, 3 minus 1 minus 1. So if I start with n and we say the current, just pre minus the current, right? So pre minus, so n minus n plus 1 minus 1, and then we do this. Okay, so pre is this. We probably need to have a result as 0 because we need to count, right? And then we say for pi again. No. So for I in range, index in indices, okay? Then we say rest of plus equal to the pre minus index plus 1, and then pre will equal to index. All right? So pre minus index plus 1, right? If the index, let's say, is n minus 2, and then it's n minus 2 plus 1 will be 1. So we remove 1. Yeah, that makes sense. And after that, the pre will become the current index, and when we have the next index, it'll be this minus this, right? 3 minus 1, but only 1, because why do we do this? And then this will figure out how many we need to return, and we'll return rest, right? Otherwise, if the pi is not smaller than 0, which means we haven't found the pattern, then we need to return, is it math.inf? Yep. Yeah, they will say it's a float, but it doesn't care. I mean, we can. Because only 100, we can basically say 1000. Better design pattern will be, we'll do a max. And now we'll do 1000. It's fine. Doesn't really matter. We'll do a max. Okay. So that's number of operations. And we can say result, right, will equal to the minimum of number of operations. What the hell are you doing, man? Number of operations. Now we have 2, 5, right? Num operations. That doesn't seem to be a, I can say, how about this, for pat in, 25, 75, 50, forgot 50, 50, 75, and 0, 0, right? So for patting this, I do number of operations of pat, right? So we get this, and then we can say if res is smaller than max, then we just return res. That most likely is the best solution, right? Otherwise, if result is max, right? If it is max, that means we haven't found any. Then we say if 0 is enum, then we return n minus 1. Otherwise, we'll return n. Okay, so this is my solution overall. We will test it here first and see if it makes sense. Name nums is not defined. Okay, it's not defined, which is okay. I actually also want to say this should be on, right? Okay, go again. So this is not good. Expected is 2, 3, and 1. And my answer is, lordy, that is, really? Okay, we have some bugs here. We have some bugs here we need to deal with. Because I don't know. What we can do is we will print. Okay, yeah, let's do a print debugging for this, because I think print debugging is good enough. Okay, it's good enough. So basically we'll print indices. Okay, and of course we need to print pattern as well. All right, so 2, 5, we need to remove basically 1, 2, 3, 4, 5, because we have 3, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Okay, 6, 5, 4, 3, 2, 1. Right. So for that, we need to remove. Actually, I need. Sorry, I need a rest as well. But in fact, I don't have to define it here. I'll define it inside. All right, show me. So now we only have 2, 4, 3, 6, 5, 4, and 3. So how in the world we get a 6? So pre is n is 7, right? 1, 2, 3, 4, 5, 6, 7. So what we're doing is 7 minus 4. So 6, 5, 4, 7 minus 4. Oh, you shouldn't be 7. 7 minus 4 is 3. Hey, wait, hold on. Oh, it's minus 1. Shoot. It's minus 1. Yeah, my bad. It's minus 1. Okay, try it again. All right, we are going to just, do something like that. Probably won't allow it start with 0, I guess. Okay, so just some random stuff. Okay, that seems to be right, and we are going to submit it. And it came back good. Yeah, I mean, definitely I think there are better ways to do this? No, I need to do a copy and paste, unfortunately, because I think something is different. Yeah. So what I want to explore now is the possibilities of doing only one pass, right? One pass. If we're doing one pass, we get, yeah, we can do only one pass, right? Hold on. Always a fan of doing something different. Okay, let's try another method. Okay, so this will be 2, and we'll say no, same method as solution 1, but with faster, but most likely faster. Okay, so we have these two, which is good. And then what we're gonna do is indices, right? So we can call indices is, let's use default dict, right? Let's use default dict of a list, okay? And then what we're gonna do is for, and we want to go from right to left, right? We'll go right to left. So it's a for I in range n minus 1, minus 1, minus 1, right? And yeah, we'll just do this. Indices num I dot append I. Okay? So now we have everything. Then we need to search for the patterns, right? Now we need to do a 5, 2. Then we get 5. Then we get 2. Right? We do def numops pattern. Okay, that's fine. But I think this will give a better performance because we have indices now, right? So now with pattern, okay, so we basically get hey, we know the patterns only, well, we can say the second digit and the first digit, right? So we can just say index 2 shall equal to indices pat 1 0, right? That's index 2. And then we say, do we have an index 1, right? Then we say for index 1 in indices pattern 0, right? If index 1 is larger than index 2, then we say res equal to 0. You know, it's the same thing. We can actually just return, because we know what this value is. We just return n minus index 2 minus 1 plus index 2 minus index 1 minus 1, which, because these will be cancelled. Okay, so basically becomes n minus this minus 2, right? So we do that. Otherwise, we'll return max. We haven't found any. Okay. Yep. So we do that, and the remaining is the same. So we'll basically copy and paste this entire thing down. Okay. And I used the same mistake. Okay, let's give this a shot. All right. Supposedly, this is easier. Not easier. I think it should be faster solution. What the hell is that? Oh, yes. Yes, yes, yes. It might not exist. Huh. Okay. Yep. So it has to be if part 1 is in indices, then we do all this. Yep, it might not exist. And still, that is interesting. It is already in indices, but it still said list out of interesting. What is this? Part 1. Yes. Yes. If it's in, then it definitely should have. All right. I don't know which one. Give me the problem. So I'm going to just delete all this and take a look. And that is not right. Whatever this is not right. Huh. Okay. We're gonna have to debug this. Damn. Okay, it's fine. It's fine. Let's just first of all, let's take a look at the indices. Make sure indices is correct. Indices. So we have 7, right? 4. I have 0. I have 5. Okay. So this is all good. And then we do the pattern, right? So pattern comes in. I probably have some issue with this. Well, we'll deal with this later. So the pattern comes in, right? Pattern 1. Let's do it's 5 0, right? So pattern 1, that's a 0, and a 0 is in indices. Index 2 equals to indices pattern 1 0, which is 4, right? This should be 4. And this in this pattern 0, which is 5, so this should be a 3, and a 3 is larger than, oopsie doozy, I think I got something wrong here. It should be smaller. Yep, it should be smaller. Okay, so now what we need to do is to figure out which one gives us the issue. All right, we need to figure out which one gives us the issue. All right, we have that index out of range stuff. Okay, we did how many? 1, 2, 3. The fourth one. Okay, so the fourth one is giving us issue. So we have 1, 2, 3. That is fine. Okay, let's try this one. 4, 5, 2. No. Oh, it's the third one. My bad. Yeah. It's the third one. It's 1 0. 1 0. Huh. 1 0. How? Why would you give me trouble? Okay, that's fine, right? And we try 5 2. 5 does not exist. And okay, we need to know which one. Pat 1 indices. Okay, what's pat? Mm. 50. 75. 0 0 is our issue. How? 0 0 is our issue. Part 0 0. Part 1 is 0, right? And 0 0. Wait, what? Huh? I don't understand. What the hell? No, it's 7.5, right? It's 7.5. 7.5. Oh, it's default dict. Gosh. Okay. It's default dict. Oh, I know. Pat 1. If this, yeah, we have to do length because you call it once. Yep, this shall be right. I know why. All right, let's get back, everybody. Run one more time. Looks good. Hopefully this will be faster. Huh. I think it's wrong. Oh, it's right. Yeah, good. It is faster. Okay. All right. That's pretty good. Oh, we have to redo this thing. And it's solution 2. Same complexity. We just use a default dict. All right. That will be it for today. I'll see you guys tomorrow. Adios.